we're going to look at nomenclature. Nomenclature refers to naming, like a naming system, and what we're going to do is learn how to go between a name of a compound and the chemical formula of a compound. So when we say chemical formula, we mean, like over here on these polyatomic ions, the numbers with and letters with the charge, those are the formulas, and these are, of course, the names. Anyway, let's talk about the polyatomic ions really quickly. Polyatomic ions are groups of atoms that have a charge overall, and I drew one here, this nitrate. Those atoms in nitrate, the oxygen and nitrogen, are really connected together tightly. So in a lot of compounds and even in reactions, this group kind of acts as one unit. And so when we go to name them, we'll name them as a group. Instead of talking about nitrogen and oxygen, we'll refer to nitrate. And then on these polyatomic ions, these are some common ones you need to know. And you may notice that there are some sets that are kind of similar, nitrate and nitrite. And if you look at the formulas, it'll help you kind of remember which is which and all of that. What I say is memorize the 8 form, nitrate, NO3, -1 charge, because it's more common. And then to get the ite form, you just have one less oxygen, same charge. Same thing if you remember sulfate, SO4 - 2. One less oxygen, same charge for sulfite. But anyway, so we'll be referring to those. And we also need to use our periodic table quite a bit in nomenclature. And that's because we can get a lot of information off of it. So one thing that you use a lot is knowing where the metals and nonmetals are. So you need to know that the metals are all here. Everything to the left and below that stair step, except you need to know that hydrogen over here is a nonmetal. So all of those are nonmetals, and then we have our metals. And that's important because when you go to name and write formulas, that's the first thing you have to do is decide if you have metals or nonmetals. The next way you use the periodic table is to determine charges. And let me put the pattern up here. This first column, we'll call that the +1 column. Next door, +2. And then you go over here for +3. Skip 1, -3, -2, -1. And so what we're saying by this is that for these elements, all of these halogens, if they form an ion, it will be a -1 ion. We will assume that it is. If these elements form an ion, it will be a +2 ion. So I say if they form an ion because they don't always have those charges. It depends on what kind of compound they're in. Oxygen is in the -2 column, but certainly oxygen sometimes is neutral. If it's in an ionic compound, though, its ion form is -2. So anyway, we'll be referring to those charges as we start to name. Now I'm going to just kind of go through a summary about the differences between the two main types of compounds. We have ionic compounds, and the other type is covalent. They're named this after the bond type. Sometimes we call covalent ones molecular. Anyway, same thing. So what are ionic compounds like? Well, first of all, they have a metal and a nonmetal. Covalent compounds only have nonmetals. Ionic compounds have ions. They have charges. Covalent compounds, there are no ion charges, no full charges like +1, -1. We'll talk a little bit later about where there can be partial charges, but we're going to ignore that for now. On ionic compounds, you use the charges to get the subscripts. in the formula. And by subscript, I mean like that 2 is a subscript. We figure that out from the charges. On the covalent compounds, we use prefixes like di, tri, etc. To get the subscripts. So you can see that the part where we go between the name and the formula is very different for the two, and that's why the very first thing you should do is determine which category you're in. You're going to have different rules. So let's start and look at an example. Okay, here's a name. The first thing I should do is determine if it's ionic or covalent. And if I look it up, potassium is a metal, and nitrogen is a non-metal. And I did that from my periodic table. Potassium is here and nitrogen is there. So I know that this compound will be ionic, because metal, non-metal. So while I'm here, I'm going to look at their charges. Potassium forms a +1 charge and nitrogen forms a -3 charge. Then we can go back to our formula. We're going to write them in order and put the charges we looked up here. Okay. Notice that in the formula and the name, the metal is first. They're always in the same order. Okay, and then our next step after we write them positive first is to adjust our subscripts to make it neutral overall. So in other words, what I'm doing is I'm looking at this whole side, the positive part, and I'm comparing it to this part, and I see that this one has a -3 charge, where this one is +1, and I want those to be neutral overall. So what that means is that apparently I need another, I need 3 of the potassiums. Okay, and if I have 3 of the potassiums, then the positive part is +1 times 3, so it's +3, and I've got 1 of the nitrides, it's -3, so it's neutral overall. So our steps there were this is for an ionic compound. Write with the charges the positive one first. And then we adjust the subscripts to make it neutral overall. Okay, so we're done with this one. That's it. I'm just going to write it, kind of clean it up. It's not wrong to show the charges in the formula in a compound. They could be there, but I just kind of clean it up to write my answer. One more thing I want to show you before we go on. This ending was not nitrogen, it was nitride. And whenever you see the "ide," though, that means it's an element. As opposed to, don't need it either, as opposed to a polyatomic ion, the polyatomic ions with nitrogen are called nitrate and nitrite. So when you see the "ide" ending, it's normally just the element. If you see an "ate" or "ite," it's a polyatomic ion. So that's kind of something to watch for. Let's try another one. Okay, copper 2 sulfide. Well, we can tell right away that this is an ionic compound because I know metal, copper is a metal. The thing you need to know is that this Roman number goes with the copper. It's its charge. Okay, and then sulfur, again, I noticed that "-ide" ending, so that's telling me that it's an element, not a polyatomic ion. Sulfate and sulfite are polyatomic ions. This is just the element. Let's look back at our periodic table. On our periodic table, copper is here and sulfur is here. So sulfur is in the -2 column on the periodic table, but copper is not in a column to tell us the charge, and that's why we have the Roman number. Most of these metals in this part can have more than one charge, and that's why we use the Roman numbers. So we're ready to write our formula. The metal goes first, and we know its charge is 2 because of the Roman number. And then sulfur, it's just the element. It's not SO4 or SO3, just the element. And we looked up its charge while we were there. And this one is already neutral. It's a +2, -2. So I'm just going to clean it up. I don't need any subscripts, and I'm finished with that one. While I'm here, let's look at what if this name had been copper 2 sulfate. Okay, so very similar. Copper 2, I know that it's a metal like before, so I'm going to put with the +2 charge. But then I noticed that it has an 8 ending, which I should recognize. That means it's a polyatomic ion. So let's go back to our chart of polyatomic ions. And I look for sulfate. Here it is. And I see that it has a -2 charge, SO4 with a -2 charge. So that's what I'm going to use. So here. Okay, and once again, I look at the charges. I have +2, -2, so I don't need any additional subscripts. This subscript is there not because of the charge, but because it's part of the sulfate. It's part of the polyatomic ion. Let's try another one. Okay, once again, sodium phosphate. Sodium is a metal, so I know this is ionic, which means that I know I need to look up its charges. And like I said, the first thing you should do is decide if it's ionic or covalent, and that's by looking if there's a metal or not. The other thing I noticed with this one is it ends in 8, and that means it's a polyatomic ion. If I look on my table, or if I have it memorized, this is phosphate. Okay, so let's put together this formula. Sodium will be first, metal's always first, and then phosphate. And its charge is part of its formula, but I need the charge of the sodium, so I look on my periodic table. And sodium is right here, so it's in the +1 column. And so I'll put a +1 charge on my sodium. And then the next step is to figure out the subscripts to make it neutral overall. And so to make this neutral, what I need to do, and again, this is what I'm doing. I'm saying this part is +1. And this part is -3. So it looks like I need to have 3 of the sodiums in order to get it up to +3. And so I'm going to put a 3 right there. And if I want to rewrite it just to clean it up,